Let's draw the diagram. We'll make O the center of our circle. So we have OT is perpendicular to TC. Let's extend CT out here and draw BQ perpendicular to CT. Let's let H be the distance from A to P. Since we have OT is parallel to AP and the distance from B to O is the same as the distance from O to A, these are the radii of the circle, then OT is the median of the trapezoid BQPA. Since it's the median, the distance from O to T is the average of the two bases of this trapezoid. That's BQ and AP. Let's solve for BQ, and we'll substitute R, the radius, for OT, and our variable H for AP. I'm going to draw this segment from A to S that's perpendicular to our radius OT. So the length AS is the same as the length TP. Looking at right triangle OSA, we have that the square of OS and AS add up to OA squared. The distance from O to S is R minus H, and we'll substitute TP for AS here. OA is a radius, and now we'll solve for the square of TP. Simplifying and factoring, here's our expression for the square of TP. Since we're interested in the distance from B to P, let's take a look at right triangle BQP. I'll reproduce it here. Now we'll plug in our expression for BQ, that's 2R minus H, and we'll use the Pythagorean theorem on this triangle. Again, since T is a midpoint, we have that QP is 2 times the distance from T to P. And squaring both sides, and we'll substitute. First for BQ, and then for QP, TP squared is this. Let's factor 2R minus H from both of these terms, and this is our expression for BP squared. A key formula for the AIME is the AMGM inequality. To take advantage of this, I'd like to be able to eliminate one of these variables. I think the H is a good candidate if I can get this coefficient to be equal to -3. I'll multiply by a factor of 1/3 and by 3. Now I'll apply AMGM by taking the square root of just these two factors. And that gets rid of one of the variables. So we'll square both sides, and we'll multiply both sides of this inequality by 1/3 to get an expression for BP squared. And we'll substitute 9 for the radius, and we get the maximum value of m squared is 432. If you'd like me to solve any other math contest problems, please leave them in the comments.